Okay, so in this video, our goal is to learn how to solve systems of linear equations. And we talked about linear equations in Unit 2. A linear equation is basically something that can be written in the form y equals mx plus b, okay, or in slope-intercept form. That's what a linear equation is. There's actually several different methods used to solve them. The first one that we're going to learn in this section is solving by graphing. Okay, and here's the procedure right here. Here's kind of the goal of what you're trying to do. You want to take both equations, and normally you don't have to do this, but normally it's easiest to change them into slope-intercept form. That tends to be the easiest form to graph from. So that's step one. Step two is to actually graph the two lines. And step three is see where they intersect, because whatever coordinate they intersect at, that is your solution. So you can see there are three pictures here. There are three possible situations that could result when you graph two lines. Situation or scenario number one, that's symbolized by letter A, is you can see I graph the red line, I graph the green line, and they meet at that one point right there. And that one point is the solution, whatever the x and the y coordinate is. We don't know in this case because that's just a generic picture. But this case would be a case where we have one solution. Okay, scenario B is when these lines actually never meet. And you may recall from Unit 2, the only case where lines never meet is when they're parallel lines. That symbol, by the way, right there, those two lines right next to each other that I just circled, that's a symbol for parallel lines. So if you graph two lines that turn out to be parallel, they actually never meet, which means there are no solutions. And then the third and final possibility, possibility C, is that you graph both lines and you discover that it's actually the exact same line. So here's an example of that. Let's suppose I have y equals x plus 2 as my first line, and I have 2y equals 2x plus 4 as my second. If you solve this second one for y, you would divide everything by 2. And when you divide this by 2, you find out that this is the exact same as that. Okay, so when this exact same line, what happens is that every single point on this line, all along that red and green line, the points agree. And so there's actually an infinite number of solutions. Every single point on that line is a solution. So that's important to know. When you graph lines, when you graph linear equations, there are three things that could happen. You could have one solution, and that's like case A. You could have no solutions, like case B, when they're parallel lines. Or you could have infinite solutions when the two lines are the exact same. So keeping that in mind, let's practice doing a couple of these right now. And I would recommend that you try to pause it and see if you can change those into slope-intercept form, because that's something that we've done before. All right, so hopefully you gave it a try. So let's change it into slope-intercept form. Remember, that looks like y equals mx plus b. So in order to change it, we want to get the y by itself, because in this example, slope-intercept form, y is isolated, it's by itself. Okay, so in order to do that, I'll subtract the x from both sides. And notice that on this side, we're going to have a negative 3y left over. We have to include that negative. On this side, we're going to have 9 minus x, but I'm going to put the x in front. I'm going to put the minus x in front because that's usually how it works in slope-intercept form. You can see it's mx plus b rather than b plus mx. So negative x plus 9, almost in slope-intercept form. It's y equals, not negative 3y equals. We have to divide by negative 3, and that means we have to divide each of these by negative 3. So our answer is going to be y equals, this number in front of x is actually a 1. So we get negative 1 over negative 3, and a negative over a negative is a positive. So that's positive 1/3 x, and then 9 divided by negative 3 is negative 3. So this right here is our first line. That's the top line. We'll graph that. It has a y-intercept at negative 3. And by the way, the y-intercept is right there. Remember, it's mx plus b. That's the b value. And then our slope is rise over run. So this means a rise of 1, go up 1, and go over to the right 3. So I'm going to go up 1 and go over 1, 2, 3. And it's a good idea to do this several times when you're graphing. So go up 1, over 1, 2, and then I'm off the graph right there. And let's go the other way too. So going up 1 over 3, that's equivalent to going down 1 and to the left 3. And you can see that those match up, and then we just connect the dots. And there's our first line. Okay, second line is, let me clear clear some of this writing up here so we have more space to work. Okay, so the first line is the one that's been boxed off. The second line, we have to do the same thing, change it to slope-intercept. Well, I'll use this in a different color. Same procedure, we would subtract x from both sides, and we'll get negative 3y equals negative x minus 6. Solve for y by dividing by negative 3. And this again simplifies to y equals 1/3 x, same as on the first problem. And then negative 6 over negative 3 is positive 2. So there's our second line. It has a y-intercept at 2. And the rise over the run means go up 1 over 3, go up 1 over 3, and let's go down 1 and to the left 3 also. Okay, now you may notice something, hopefully you notice something, and that is that these two lines, the red one and the green one, they have the same slope. In both cases, the slope, or the m value, is 1/3. What kind of lines have the same slope? Parallel lines do. And on the previous page, you might remember that this is case B. In case B, there are no solutions. Those lines never touch. They're never going to meet, and so we don't get a solution. Okay, example 2 right here is going to have a solution, and we'll find it right now. So let's do the same thing. Let's change it into slope-intercept form, same as we did right before. So we'll subtract x from both sides, and we get 2y is equal to negative x minus 6. We'll divide by 2. So we end up with y equals, remember this is a negative 1 right here, so that's like the fraction negative 1 over 2, or negative 1/2 x. And then negative 6 divided by 2 is negative 3. There's our first line. It has a y-intercept at negative 3, so I just put a dot at negative 3. And then the slope is negative 1 over 2. So that means negative 1 means go down 1. Positive 2 means go to the right 2. Okay, down 1 to the right 2. Or again, we could go up 1 to the left 2 because that ends up being the same line. You can see when you connect the dots right here, you end up with that blue line right there. Okay, let's graph the other one. So use a different color here. Let's use red again. So subtract 7x right here from both sides. We'll come down here and make a little bit more space. We get 2y equals negative 7x plus 6. We want it in slope-intercept form again. So slope-intercept is y equals, not 2y equals. So we'll divide by 2. And that means we'll divide this by 2. So you get y equals negative 7 over 2x, and then 6 divided by 2 gives us 3. So that has a y-intercept at 3, and the slope rise over run, this means go down 7. So 1, 2, 3, 4, 5, 6, 7. And then this right here means go over 2. So 1, 2. And you can see we actually met right exactly on that point right there. So we connect the dots right here. We do get a solution, and that solution is whatever that coordinate is. So we can see it matches up with x equals 2. So there's the x coordinate. And it matches up with, right here, y equals negative 4. That's the y coordinate. That's how we solve systems of equations, by graphing. Change them both to slope-intercept form. Graph them. If they don't meet at all, there's no solutions. If they do meet, like number 2, then there's one solution. So that's the first method to solve. In the future videos, we'll talk about some of the other methods as well.